So, welcome to graphing absolute value graphs. In all honesty, it's probably more than that. It's given a function, all right, find the absolute value, and you'll see from the examples what we mean, because it's not just one set absolute value, there's a few others. So I think the learning goal is more accurate by using a table of values or otherwise graph absolute values of functions and other variations. So yeah, really important that we're going to be a bit moldable, and we're going to sort of try think outside the box a bit. All right, so let's get into it. This is our first example. So we've got this function here, all right, and I've got its drawing there, okay, and you can see that it's the right one because from here you can clearly see that it has roots at x equals 0 and x equals 2. So that's where it crosses the x-intercept, okay? And so we're just going to do a table of values for it, and just, yeah, it might be wise to expand it out, x squared minus 2x, all right? And we're just going to do a table of values for it. So when x is -3, so we sub in -3 into here, we get 9 minus 2 times, and because of the double negative here, it's going to be plus 6. So it will be 9 plus 6 will be 15, okay? Which is why this one doesn't have that, but let's keep going. And so that would be 15. They go minus 2, we get 4 plus 4, which is 8. And that's actually what we get here at minus 2. We get 8. All right, so that works. And then let's just keep going with it. At minus 1, it's going to be 1 plus 1, which will be 2. And just like that, 1 will be here. No, 1 plus 2, so it will be 3. So I've done that wrong. It will be 3. And you can see from here on the graph that it is 3. And then at 0, it will just be 0, which is correct. And then we go back to 1. So 1 squared minus 2, it'll be minus 1, which it looks like it is right here. And then at 2, it'll be 2 squared, so that's 4 minus 4, which is 0. And that's good because that's the second root. And then 3 will be 3 squared, which is 9, minus 6. So that will be 3, which is what happens here at 3. It goes up to 3. And then it's symmetrical all the way from this line here, just like any other parabola, okay? Now, what will f of x with absolute values look like, okay? Well, the truth is that these absolute values, what they do is that any positive or negative numbers, it turns out to be positive. So like, for example, from before, if we had the minus 5 equals 5 in the absolute values, minus 6 equals 6, all right? And in the same way, the absolute value of 5 is still just 5. So if we do the table of values at the bottom, we get the same thing. So 15, that's positive. 8, that's still positive. 3, 0 is just neither positive or negative. Now, here is where it changes. This next one, what is the absolute value of -1? Well, it's just 1, okay? And we can see on the graph here that at 1, instead of being down here, it flips up to here, all right? Because of the nature of the absolute values. And then everything else is fine. 0, it's still the same 0. 3, it's still the same 3. And that's why you can see that this blip up here, it flips up. So almost happens is that the x-axis becomes like this sort of trampoline that it just bounces over, and this bit here just flips over to the top, okay? So just something to be aware of. Okay, there's a second variation that we can use with absolute values, and I just want you to have a look at it. So instead of it being absolute values here at the edges, it's just the absolute value of x. So what I'm going to do is I'm going to do that up here. So the absolute value of x, so the absolute value of -3, well, that's just 3, isn't it? So the absolute value of -2 is just 2. The absolute value of -1 is just 1. So what I'm going to do is I'm going to fill out the table just like we were here, because we're using the same function. So this one was 15, this one was 8, this one was 3, 0, at 1 it was -1, at 2 it was, I forget, what was it? 0, yep, obviously, because it was a root. And at 3 it was back to 3. Was it? Yeah, that's right. Okay, so how does this work? All right. Now, we could have done the absolute value of 0 equals 0, absolute value of 1 equals 1, the absolute value of 2 equals 2, the absolute value of 3 equals 3. Okay. Now, this is going to help us. Okay. Now, the only ones that have changed, because notice that all the ones down here are the same, okay, the same as what they originally was. The only ones that will change are these ones here, because that -1 has changed to 1, that -2 has changed to 2, that -3 has changed to 3. So what I'm going to do is we're going to put exactly the same values as we had for these ones here, okay, the positive ones. So it will be 0, -1, 0, and 3. Now for these ones, see how they've changed for this one. So what we're going to do is that we're going to put the same value as +1. So we're going to put the same value as we got with this one. So that's -1. Notice that one we got, the answer was -1. And for this one, we're going to put the same value as 2, because obviously the absolute value of x is now 2. So that's going to be 0. And we're going to do the same for the -3, so it's going to be 3. Okay? And what ends up happening is that the y-axis ends up becoming like some sort of mirror, okay? And the reason for that is all the absolute values of x, the absolute values of -x become +x. So it does the same thing. So this is what it did before, and on the negative side, it does the same thing as the positive side, okay? So it becomes some sort of reflection there. All right, let's look at one last one, and probably the trickiest one to think about, but let's give it a go. Okay, so we've got the same function once again. So I'm going to fill out all these details. 15, 8, 3, 0, that was 0, -1, 3. Okay. Now, y is, what I'm going to do is that I'm going to put, I've got y here. So y will be just, y and f of x are often very interchangeable. Okay. The only difference is that y can still remain y even if it's not a function. All right. So for example, with a circle, that's not a function, but we can still have y. Okay. All right. So what I'm going to do is I'm going to make space, and I'm going to put the absolute value of y underneath that, and I'm going to fill in the details of y. Now, y is just f of x and y interchangeable. 0, -1, 0, and 3. Okay. Now, the thing is, the absolute value of y means that we can have both 15 or -15. All right. Because the reason for that is that we're going to get, whether we get the absolute value of 15 or the absolute value of -15, we're going to get the same answer, all right? And it's the same for this, 8 or -8, 3 or -3. 0 doesn't really matter, it's just 0, 0 doesn't really matter. 3 will give us 3, or the absolute value of minus 3 will also give us the answer 3, okay? So we almost got to think backwards. Now, what about the negative, okay? Now, the negative can't exist, all right? Because the absolute value, I'm going to write up here, the absolute value of any number, so let's go, of minus x cannot equal a negative number. That is not true, okay? So we can't have a negative number, so can't have it. Negative, all right? And we can highlight that. And if you see from the graph, what it does, and if we look at it, see this bit over here? It exists in this one here, but also the bit down the bottom, okay? Because of this situation where we can have 3 or negative 3 to give us the same answer of 3, all right? So we can have negative 3, the y value of negative 3, here, or the positive value of negative 3, they both equal 3, all right? Same thing happens on the other side. We can have the positive value or the negative value, okay? So it's almost like this becomes like a picture on the water where you've got the real picture at the top and then the mirror image at the bottom here that reflects the same thing. Now, the only thing that we can't have is the negative part, all right? So we can't have this negative part down here. So you can see that it doesn't exist, all right? So anything that's below the x-axis, and so it becomes into the negative y realm, won't exist in these type of graphs. So in these type of graphs, okay? So that's the main thing that you've got to remember, and that's because the absolute value of y, all right, so the absolute value of y cannot give you a negative number. So that's why it's not possible to have a part of the graph that exists there. Anyway, hopefully this gives you a little bit of insight. Peace out.